like all my presentation, I want to dedicate this presentation to my guru, late Professor B.V. Pandey sir. His contribution to this concrete pavement is very immense. That is why he's also known as a father of concrete pavement. So with all his blessings, let's start the work for today. Before starting, I want to give credit for the tables are taken from IRC 44 and SP 49, and images are taken from Google only. For the today's session, I'll talk about the introduction, what are the kind of pavements we have, what are the recent advancement, what are the traditional pavements, then what are the possible outcomes of the recent advancement and the traditional pavements. Then we will come upon with a mixed design procedure based on IRC 44. Then we'll solve one example, and then we'll come up with DLC mixed design procedure. Now, in recent times, India has been suffering a lots of flood fury. So because of that, stormwater runoff is major problem. And we know that development of any country is totally dependent on the connectivity. So ex-president of USA, one John F. Kennedy says that American roads are not good because America is rich, but America is rich because American roads are good. So he meant this statement by saying that he knew the development of any country is totally dependent on the connectivity of the road. Since India is globally the second largest road network, which comprises of around 5.5 million kilometers. So government of India is taking a vast initiative to convert most of the flexible payments into concrete payment to get rid of the distresses which is occurring very often. So Indian road network is comprising of national highways, expressways, state highways, major district road, other district road, village roads, and many things. And annually, every time the road length has been increasing day by day. We can see that major projects which are sanctioned by Morthar, such as Bharatmala Pariyojana, Char Dham Pariyojana, and government of India is constantly trying to link the field person to the institute. For that, lots of MOUs has also been signed. So recently, IIT Roorkee has signed a MOU for research and development and teaching and training for the infrastructure. Now, I want to ask a few questions regarding. So for that, I'll also need some volunteers. So let's start with what are the types of payment do you know actually? Anyone?
Flexible payment and rigid payment, sir.
Yes. So flexible payment is a bituminous payment. In USA, it is also called as asphalt concrete. So this is flexible payment and rigid payments, as you mentioned, which is also known as plain cement concrete and concrete payments. There is one more type of payment. Semi-rigid as in? Yeah, yeah. So this very well answered. So this kind of payment is a combination of both, which is also known as composite payments, which is also known as perpetual payments. So in recently, the sub base is also being stabilized with cement just to get the good bond structure. So what is the basic difference between these payments? Anyone? Between rigid payment and flexible payment?
Load transfer analysis is different for both type of the payment.
So apart from the uh, 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 basic physical difference of different layers, different formation levels, different base course and sub base course, the main basic difference is the, as correctly mentioned by sir, it is a load transfer mechanism. So what is the load transfer mechanism for the flexible payment?
Grain to grain.
Yeah, it is a aggregate to aggregate interlocking transfer. And for rigid,
Slab action. Through slab action.
yes, through slab. And what about the load transfer mechanism for composite payment? Anyone? So for composite pavement, initially it will transfer from aggregate to aggregate, and later on it will get into a slab action, and it will form a sub-trapezoidal kind of structure. Okay. So, and tell me, now talking about the rigid pavement, since our work is today's lecture is based on completely mixed design of rigid pavement. So what kind of rigid pavements you know? Some traditionals.
CC road.
Sorry, cement concrete.
Roller, roller
What kind?
compacted concrete pavement, RCCP.
RCCP are, sir, I think it's not traditional. It is still on the experimental stage, right? So I want to know about some traditional which are being used from the past. RCCP, pervious concrete. These are recent developments, right? Sorry, panel concrete is also one of the newest kind of concrete.
Sir, it could be CC blocks.
This again, it is come upon the recent development. So traditionally, traditionally, some of the rigid pavements are JPCP, which with dowel bar, which is also known as joint plain concrete pavements, and another it is joint plain concrete pavement without dowel bars. Okay, some of the traditional pavements are reinforced joints, reinforced concrete pavement. Some are continuously reinforced concrete. Some are pre-staged concrete pavements. So these JPCP with dowel bars is being used for the whatever conventional concrete pavement we see. These all are mostly JPCP. So why do we need to provide the dowel bars, and why don't we provide dowel bars?
For low volume road, double bar is not necessary if the capacity is 211.
Anyone else?
For load transfer, double bar are provided.
Okay, from one slab to another, right? And what is the function of tie bar then?
Tie bar is the longitudinal for joint connection between the two type of slab. If the width is more than single lane.
Very good. So tie bars is, as the name suggests, it is just to tie two bars. It is not meant for load transfer. Okay. So for dowel bars, we generally transfer around 50% of the load is been transferred from one slab to another. Then why aren't we providing dowel bars in JPCP without dowel bars? So why do we have all these kind of pavements? And then why do we provide reinforcement? So jointed means it is jointer, okay? So with dowel bars, it is for generally heavy volume roads, high volume roads, or state highways, national highways. So when the number of commercial vehicle per day, commercial vehicle is less than 450, we don't have to provide a dowel bar. Okay. Similarly, to arrest temperature cracking, reinforcement is done. So it is known for jointed reinforced concrete pavement, and some are for continuously concrete pavements. So as you guys mentioned, the recent advancements such as roller compacted concrete pavement, some of the pavements are pervious concrete pavement, some are precast concrete pavement, overlays and block pavements are also there. So these all were for the basic, like what are the types of rigid pavement we have. So talking about the mixed design process, first we need to understand what are the layered design of the pavements. May I know what is this? This layer, and what is the design criteria for this all above layers? Anyone? This layer is the embankment, right? And the design procedure is based on CBR method. Hello, am I audible?
Yes, sir.
Yeah, this is CBR, okay? So we have an embankment of 500 meter and design is based on CBR. And this is, what is this?
Subgrade.
Subgrade, right? Subgrade is and its design is based on again CBR. So may I know what is the depth of CBR or subgrade? Sorry, it is up to 300 to 500 meter. Okay, and what is this then?
Base course.
Granular subbase. Okay, so granular subbase it act as a drainage layer, and the thickness is 150 to 300 meter. So, and again the design criteria is CBR and permeability. Now these two layers we have to study. Okay, so tell me one thing. What is this?
Base.
No, this
Base
is
course.
DLC, which is dry lean concrete,
Base.
and it is based. Yes, the design criteria is based on compressive strength, and its thickness is around 100 to 150. Now, above DLC, we provide PQC. Okay, and its design criteria is based on basically flexure strength or sometime compressive strength. Now you can see this red dotted line is there in between the slab and DLC, right? What is this? Anyone?
Impermeable layer.
Dr. Surya, the
Permeable
units
layer.
Dr. Surya,
We are technical person, right?
Surya, the units are not correct. Kindly correct.
Sorry, sir.
Units are not correct.
Oh,
200
I'm sorry.
meter. Okay.
Yeah, yes, sir. It's a millimeter. Sorry,
Yes.
sir. I'll correct it, sir. Yeah. So this is basically a PVC sheet. Okay. So why do we provide 125 micron PVC sheet? Any idea, anyone? So PVC sheet is generally just a separation layer between the PQC and DLC. Okay. So why if what if we don't provide a PVC sheet? What will happen?
It will act like a single unit. Uh,
Yeah. So it will if the thickness will increase, right? So it will result in more shrinkage also. So the PVC sheet is act as a separation layer between the PQC and DLC. Okay, which will reduce the shrinkage of the PQC mixes. Fine. Now, talking about the mixed proportioning, what does PQC consist of? Anyone?
PQC consists aggregate, coarse aggregate, fine aggregate, cement, and water.
Coarse aggregate, fine aggregate, cement,
And water.
We have
Uh,
one more thing. What is this?
Admixture or plasticizers for workability improvement.
Yes. Yes. So can you tell me the difference between coarse aggregate and fine aggregate? What is the basic difference?
If the aggregate is more than 4.715 mm size, it is coarse aggregate, and the less 4.75 is fine aggregate, sir.
Yeah. So it is basically if 50% of the aggregate is more than 4.75, it is coarse aggregate. And if 50% of the aggregate is less than 4.75, then it is fine aggregate. Okay. So talking about the principle of mixed proportioning, can I know how to blend the material together? Like in the field, like how do you blend the mixed material together?
With mixture machine.
Yeah, but like first, what you put? Which material do you put in the mixture?
Coarse aggregate, then fine aggregate, then
Then
Cement.
then you put
water.
some water. then cement, right? Yeah. So first we do the blending of different size of aggregate of 31.5 mm, 12.5 mm together with so as to consider the minimum number of voids, right? In step 2, we try to fill the voids with the cement and we add some water to make it as a mortar so that the voids are filled with mortar paste. Now in step 3, we adjust the concrete matrix for workability, strength and durability properties. Now, what is the traditional mixed design approach?
Nominal mixed design, it is based on the volumetric basis.
Yeah. So basically, earlier the mixed design was done on the volumetric approach. Basically, we used to do like 2:4:6, which is 2 is the cement content, 4 is the fine content, and 6 is the sand or coarse aggregate or gravel content, right? So, so what do you think? Which blending this blending process is right?
No, nominal mix is not always good, but for the low category of work, it is better.
Yeah. So generally, what we do, we try to do for the volumetric approach, but on the field, the weighing approach is generally preferred. So this is actually not correct because the specific gravity and the water absorption things are not generally considered. So we generally prefer the volumetric approach, and then for the mixed design, then for the field, we convert it into specific gravity, and then the weighing thing has been done. So what are the factors governing the concrete mix design? Any idea? So for
Gradation.
tell me for PQC, which kind of concrete mix you prefer? This one or this one?
First one, sir.
First one. Why not this one?
Uh, because this is more workable, but it won't give much strength.
Yeah. So degree of compaction and effort is the one of the major important factor which governs the concrete mix design, right? And water to cement ratio, and this is Abraham's law. As the water cement ratio increases, the strength will reduce. So water to cement ratio is also the one of the governing factor. Some of the aggregate properties such as shape, size, strength of aggregate, surface texture of the aggregate is also a very important governing factor. And for the cement, fineness and cement property, grade, and different supplementary cementitious material if used is also important factor. So for batching thing, what batching approach do we prefer? As sir mentioned, we do volume method and for weighing method. So which of the method is right? Which method is good?
For less quantity of work, volumetric is okay, but if the need of the concrete is in mass scale, then weighing is must.
So you tell me if we consider one and but why? Tell me if we consider the low
Because
density aggregate, okay, and one is a high density aggregate, and we have to take a 50 kg of aggregate in one go, and for example, if we weigh 1 kg of high density aggregate, it would be equal to 2 kg of low density aggregate, right? Let's say we have to take 50 kg of both, and then 1 kg of high density aggregate would be equal to 2 kg of low density aggregate. So I mean to say here that even if the volume occupancy is the same, because the shape and size is the same, which also means low density aggregate will be more. Then where is this 50-50% proportion? If we want to take 50-50% of both, then the low density aggregate, for example, if we have to take 2 kg of LDA, and it would be equal to 1 kg of high density aggregate. So to minimize this condition, we have a specific gravity. Okay. So weighing batching is not exactly appropriate. So for mixed design approach, it should be avoided. However, for the field application, a weight approach is taken by conversion of density into specific gravity into 1000. Right. So, talking about the mixed proportional principle, we also know it is also famous as a job mix formula. These are the layer of the normal concrete pavement. One by one, we will decide the volume of each coarse aggregate, fine aggregate, cement, SCM, water and chemical admixture and air, and we'll find the what are the proportion of each material for making of the PQC. Right. So job mix formula for concrete mixes is based on these steps. First of all, we'll determine the volume of each ingredient. Then the volume is converted into mass. The density, which is also known as mass by volume, then the density by this formula will convert this into a mass for the field construction. Now, this standard method for mix design as per 102 IS 10262 is for building concrete. Then it is also based on 8 steps, and IRC 44 is also based on 8 steps. So tell me one thing, why don't we consider building mix design procedure as a mix design for PQC? The main difference is like for building, we designed as per target mean compressive strength, and for mix design of PQC, we designed based on flexure strength. Acha, tell me one thing, what is building concrete? Can we use it for PQC? Can the mix design approach can be used for PQC or not?
Yes, sir.
Yes, sometimes we cannot say ki we'll always use by because we have this formula, right, of 0.7 under root FCK, from where we can convert
We can get the flexural strength from that
into compressive strength into flexure strength, right? So for each of the step, we'll be calculating the different air content, then water to cement ratio, then water content, then cement content, and different aggregate and fine aggregate content with a proportion. And finally, we'll do the trial mixes and calculation. So why flexure strength is considered as a design criteria for PQC?
Because concrete pavement transfers the load through beam action. Therefore, flexural strength is must.
Yes. So as you rightly mentioned, it transferred through beam action and it fails on bending, right? So we have to design it as a target mean flexure strength. Now, for taking about each step together, for this, we will talk about first the target mean strength based on IRC 44. So the step 1, which is based on target mean strength, which also talks about the design of the flexure strength, which is based on this formula, and whichever is higher, we have to take that one only. We will get to know when we solve one problem over there. So what is target mean strength? Why do we have to consider target mean strength? And what is characteristic strength?
Characteristic strength is the strength of the concrete after final setting time, 28 days.
Yeah, as it is the strength of concrete below which 500, at least not more than 5% of the results are expected to fail. Which means if you are a supervisor over there, and if you have casted around 100 beams, and only if 5% of the beams are failed, you cannot demolish that structure. Okay. So, like for example, if 95% of the beam should be okay, like it should not fail. So this formula is the first step of the target mean strength, and we have to take the value whichever is higher. Similarly, for the compressive strength also, we have two formula where X is the X is the factor of safety, which is mentioned in IRC 44, depending on the grade of concrete. Okay, and again we have to calculate, and whichever is higher we have to take. So then tell me what, how is this? Why is this standard deviation? What is this 1.65 SD? Anyone? So standard deviation is also one of the factor of safety to take based on the code, that for the different flexure target means flexure strength, we have different standard deviation. For example, generally concrete pavement is designed for the flexure strength of 4.5. For that, we need to take the standard deviation of 0.40. If in some cases, if we are designing for compressive strength, we have a different standard deviation. Now, talking about the air content selection. So we'll be coming like from one by one to each layer of the PQC, and then we'll learn about the different proportion of each layer, right? So in the step 2, which is based off air content selection, we have a entrapped air mostly in the concrete mixes. Why? Acha, have you noticed this based on nominal maximum aggregate size, the percentage entrapped air is decreasing? Why it is happening? In concrete mixtures, we have an entrapped air, right? So like with the increase in the size of the nominal maximum aggregate size, surface area is reduces, which results in less cement paste and thus less capillary void. So that is why percentage entrapped is reducing. So for example, for maximum aggregate size of PQC,
20 mm.
For PQC,
From 22.4 say come.
for PQC, as per the code suggests, we have to take the nominal maximum aggregate size of 31.5. That this is the basic difference. This is the main difference between PQC and building concrete. Right, for building we have to take around 20, as you mentioned, 20, 25, 24 like that, and for PQC the nominal maximum aggregate size is 31.5 mm. So for air content, like for example, if we have to calculate the percent entrapped air for 31.5, and entrapped air is, as mentioned in ISC, is 0.8, so it is 0.8% of total volume, which is 1 meter cube, right? So overall we have percentage entrapped air is 0.008. Okay, then again we have to take care of absolute volume. If 0.008 meter cube is the percentage air in the concrete, then what is the absolute volume? Anyone? The absolute volume is 1 minus this, right? The total volume of the aggregate was 1 meter cube. See, the total volume of the PQC was we have taken as a 1 meter cube, and for this is 0.8% of 1 meter cube. So this is almost 0.008. So what is this total? Total is 1 minus 0.008, right?
Sir.
Now, talking about the step 3, which is water to cement ratio selection. It is a very important part because it decides your strength based on Abraham's law. Abraham's law states that as the water cement ratio increases, your strength will be decreasing. So it is basically deciding dependent on water cement ratio only. So what is this the design criteria for PQC? For flexure, we design for flexure strength, right? For example, for 28 TMS target mean strength, we design for 4.5, and for we considered OPC, so we have to take 0.39 as our water to cement ratio. Once we get the water to cement ratio, then we'll move upon the cement content, then water content, and based on that we'll find the percent proportion. Now tell me, which OPC will you prefer? OPC 43, 53 or 63 maybe, and why?
43.
Okay, why not 53?
It is more finer, then will attain the strength earlier. So curing will be problem.
Okay, so if the economy of the project is not a problem, we can consider 53 also, because it is little bit costly than OPC 43. But as you say, can you see, like we can see in 5% of target mean strength with lesser with 0.34, we are getting 5 MPa of strength. But in OPC 53, with more water also we are getting 5 MPa strength. So that's what I mean to convey is, if the money is not a problem of any project, we can consider OPC 53 for early strength. Right. In recent times, PPC is also coming. And for that, code says that for PPC, we have to take OPC 43 water cement ratio corresponding to OPC 43. And we have to make sure that water cement ratio shall not be more than 0.40 for PQC. Okay. Now we got air content. First we get the target mean strength. For if we have to design the PQC on the field, we will first set the target. Why do we need to set the target? Because we know that the mixing condition in the lab and the field is not same, right? So first we will set the target mean strength. Based on the target mean strength, we'll find the air content, and third we'll decide the water to cement ratio. Now in the fourth step, we'll work on the water content selection. Now this is very tricky one. See, for water content selection, we have a different nominal aggregate size. Now tell me, as the nominal aggregate size is increasing, water content is reducing. Why?
Surface area is more. So it is
Yes. For nominal aggregate size, as increase area will be more. Now, this table of IRC 44 is, we have to mention that this table is based on angular size aggregate only, and for SSD condition, and for 50 mm of slump. Okay, so we need to adjust based on our requirement. For example, if we don't have SSD condition, if we have a dry condition, so when we have a dry condition, we will increase the water content up to the water absorption. And apart from angular size, if we have a round gravel, if we have a crushed gravel, if we have a semi-crushed gravel, we have to reduce water by as mentioned in the code, right? For example, in round gravel, we have to reduce water by 20 kg. In crushed gravel, we have to reduce by 15 kg. Semi-crushed gravel, we have to reduce by 10 kg. Okay. And now if we have to use some chemical admixture, we have to reduce by 5 to 10% also. If you are using some super plasticizer, by 20 to 30% of water is being reduced. Now, as it is mentioned for 50 mm slump, so tell me one thing, what is the slump value of normal PQC?
$30 to $45.
30 to 40 mm?
Yes,
No,
sir.
The 25 to 30 mm.
No, 25 plus minus 10. You are right. 30 to 40 mm is not the slump value of a PQC. Please correct this, okay? For PQC, generally we consider the slump of 25 plus minus 10. Then what would be the slump of building concrete? Anyone?
So 50 to 100 mm.
Not 100, at 50 to 70 we considered for the slump of
Okay.
building concrete. Okay. Now for PQC, we have to remember this. This is the very basic. We have to consider for PQC, we have to consider the slump value of 25 plus minus 10. Okay. Now we got water cement. Hello.
सर सॉरी टू इंटरप्ट सर, एक चीज पूछना चाह रहा था।
जी जी
सर ओपीसी की जगह अगर हम पीपीसी यूज कर रहे हैं पीक्यूसी में,
हाँ,
तो उसके वाटर सीमेंट रेशियो के लिए कोई अलग से टेबल है, या जितना ओपीसी 43 का है वही पीपीसी का कंसीडर करेंगे?
Yeah, as per IRC 44, for PPC, the water cement ratio corresponding to OPC has to be considered. अभी तक PPC पे कोई वो नहीं आया है, so उन्होंने ये mention करा है कि for PPC यही वाला को we have to consider, okay?
Okay sir, okay, thank you sir.
If we have some target mean strength. Okay. Now moving forward, now we got the water content. Now we have to find the cementitious content selection. Now tell me, what is the difference between this cementitious and this cement content? What is cementitious? What is a cement? We know, right? What is this cementitious content?
सर जो हमारे एग्रीगेट्स में आ जाते हैं, जैसे सिलिका हो गया, सैंड हो गया, तो क्या उसको भी सीमेंटिशियस कंटेंट में काउंट कर सकते हैं?
Oh, wait. So cementitious content is basically if we add, you rightly mentioned, if we add some supplementary cementitious material, okay? If we add some fly ash, silica fume, then it is known as cementitious content. So as per the code, it is mentioned that minimum cementitious content shall be 360 kg per meter cube, and maximum cement content shall not be more than 450. Then why if we know that cement is increasing the strength property of a PQC, then why there is any upper limit on this cement content? अगर मुझे strength ही चाहिए, तो we can increase as much as we want, right? So why we have set up a limit?
Because of shrinkage.
Shrinkage, yes.
So it makes mortar brittle.
Not brittle. Shrinkage was the right answer. And if money is also a concern, right? Cement is costlier material. So now from here in step 1, we got this thing. We got water to cement ratio, and then we got for nominal maximum aggregate size, we got which is 31.5. We got water content also as 165, and then water cement ratio, for example, 4.5. We get the 0.39. So from water to cement ratio, we can get the cementitious content, right? See, water to cement ratio is, we got, for example, 0.39. We got the water in the previous step, right? For 31.5, we got 165 because 31.5 is the nominal maximum aggregate size for PQC. And from here, can't we get cement content if we have 165? Right? Yes or no?
Yes sir.
Yes, sir.
So for 165 water content, we have to adjust also. As I mentioned before, we have to adjust for SSD condition. If we have a dry condition, if we have a slump of, this table is for 50 mm, so we have to adjust for 25 mm. If the question mentioned that the angular aggregate size is, the shape of aggregate is round crushed gravel, so we have to adjust the water content. So finally, if we get the water content of, after so much of an adjustment, we get 130, for example, then we'll find the cementitious content as per water to cement ratio. So this is very important, right? Now, so there are some also recommendation if we have upper limit, if we have cementitious content. So we have a recommendation for different SCMs and their doses, right? For fly ash, we have to take 25% by mass as per IS 3812. Similarly, for silica fume, 5 to 10% by mass of cementitious material, we generally preferred for M50. As per the hydration process, silica fume shows the maximum increase in the strength. Why it is so? You know, like C3A, these are some bogus compound, right? And when water is added, it produces what? CSH and CH gel. So when we add any fly ash, not fly ash, any supplementary cementitious material, it add one more silica to it. So we have 2 CSH gels, which eventually increases the strength, right? So for different SCM such as metakaolin, GGBS, we have different limit as per the code. And for fly ash, since it is mostly used, and GGBS, the code has mentioned that minimum cement content should be 310 and 250 kg per meter cube respectively. So code has set a bar on the fly ash or GGBS. If we are using, code has set up that whatever you want to use, you use. But fly ash and if we are using fly ash and GGBS, minimum cement content you have to maintain at 310 or 250 kg per meter cube. Okay. So as so when we use silica fume or different SCM, one silica hydrate is added to this to increase the strength of the PQC or concrete mixtures. So this step talks about the coarse aggregate blending. Now, we move towards, we got as in this image, we got we got air content, we got chemical admixture. If the question is mentioning we have to add, we'll get it also. We got water content, we have cement content. Now till here we get. Now we have to get the coarse aggregate and fine aggregate. Okay, so talking about the coarse aggregate content blending, we have different sizes of aggregate also. Okay, so for we have to, as per the code, we have to follow these gradations, and we have to check other the parameter for the aggregate also, such as elongation and flakiness should be less than 35%. Impact value should be less than 30%. Water absorption should not be more than 2%. No, water up to only 3% is allowed if other properties are satisfied. So likewise, for fine aggregate blending, we have a different sizes, and we generally prefer zone 2 for fine aggregate. Generally, fine aggregate of particle zone is available in the market, but we have to blend it together. Okay, fine aggregate shall not have material passing 75 micron, which is wet sieving. For fine, if we considering natural sand, 3%, for crushed stone, 1%, and for M sand. What is M sand?
Manufacturing sand, manufactured.
Yes, manufactured sand, which is a blending of different types of sand. So which it should not increase 8%, for water absorption should be less than 3%. These are some parameters which is directly mentioned in the code. We have to follow that. Now we got the coarse aggregate, now we got the fine aggregate, now we have to blend it together. Right? So coarse and fine aggregate needs to be proportioned wisely so as to produce the PQC with satisfactory characteristics. Now we have to estimate the coarse volume of a coarse aggregate per unit volume of a total aggregate. Now again, the blending of this blending of this aggregate is based on the water cement ratio of 0.50. This table is valid for water cement content of 0.50. So we have to again adjust. So for adjusting, we have to proportion the volume of coarse aggregate will be increased by 0.01 meter cube for every decrease in water cement ratio by 0.05 and vice versa. For example, if we get a water cement ratio of what we got previously, for example, 0.4. So for every decrease in water cement ratio by 0.05, we have to increase the volume of the coarse aggregate by 0.01. For example, let's say our water cement ratio is 0.32. Okay, and this table is valid for 0.50. We'll mention 0.5 since it is the limit for the table. We'll minus the whatever water cement ratio we got, and we found that it is 0.18 is lesser than 0.50. So we need to increase the volume of the coarse aggregate by this. This is the calculation which we have to do, right? And once we get the volume of the coarse aggregate, we'll get the fine aggregate volume by subtracting from the total volume, which is 1, which is also known as absolute volume. Now in step 7, we will get the coarse aggregate and fine aggregate content with the completion of all the previous step. The masses of air, water, cement is known. Only the cement, fine aggregate and coarse aggregate is unknown, right? So this will be done by, as I mentioned earlier, it is done by subtracting the volume of other ingredient from the total volume and converting the remaining volume into the equivalent masses. So volume, as per this density and specific gravity formula, we will find the volume of cement such as a mass of cement by specific gravity into 1000. Similarly for water, SP or SCM has to be calculated. And volume of all aggregate is calculated by absolute volume, which is 1 minus volume of air void, which considered from here, from this point till this point, will minus the remaining volume of the cement, water, SP and SCM. Okay. So mass of coarse or fine aggregate is equal to volume of total aggregate into volume of coarse or fine into specific gravity. Now, after the calculation of all the volumes, we'll do the trial mixes and mix calculations. So your job mix design should look like this. Okay. So the calculated mix proportion have to be checked by means of different trial batches. 3-fold different trials needs to be conducted, which is measured on workability and strength, and we'll try to establish the relation between the water cement ratio and the strength, and we'll try to validate the design through different field trial also. So the water which is mentioned, which we got, would be as a free water. What is free water? Free water means coarse aggregate and fine aggregate should be considered in the SSD condition. What is SSD?
Saturated surface dry.
So what does it mean?
Surface is saturated but dry, means When we touch with finger, it will not stick.
As the name suggests, it is surface dry, right? Which means the pores is
Pores have
filled
water,
with
but
water, but the surface
surface is dry.
yes, the surface is dry. So again, we have to make a suitable adjustment with the condition of aggregate. Now we will solve this problem. I hope you are ready with pen and paper, and I'll give you some time to solve, maybe 15 minutes or 10 minutes to solve this. And these are the given data. Okay, we have to consider the grade designation is 4.5, and the type of cement we are using is 31. Type of cement is OPC 43. Maximum nominal aggregate size is 31.5 mm. The minimum cement content as per the code and the maximum water cement ratio is 360 and 0.40. Workability as a slump is 25 plus minus 10. And degree of supervision is good. The type of aggregate is crushed angular aggregate only, so that you don't have to adjust so much. And the maximum cement content is 450, and the chemical admixture type we use is super plasticizer. And depending upon the specific gravity, we have a cement specific gravity of 3.15, coarse aggregate is 2.74. Similarly, we have a water absorption value of different coarse and fine aggregates. And we'll do the sieve analysis and of coarse aggregate as per ISC 44, and for fine aggregate we have to take zone 2 as per IS 383. So let's solve this problem together. If you have any doubt, you can ask in between, okay? If you want to know any other data also. We'll start from the first step, okay? What was the first step? Come on, let's solve it. What was the first step? Target mean strength, okay? Hello. Are you solving or not? So I'll help you out, chalo. So the first step is, I'll help till first step only. So step 1 was target mean strength. We have to design based on flexure strength. We have to take these two consideration, and whichever is higher we have to take. And for standard deviation, we have to take this table. So as per the given data, we have to design as per grade designation of 4.5 Newton per mm square. And for 4.5 MPa, we have to take 0.04. So if we calculated for first part, we got 5.16. And if we have taken 0.55 as a fixed factor of safety, then we got the 0.05. So first step states that whichever is higher among these two, we have to take as a target mean strength. So for this question, we have 5.16, which is 5.16 MPa as our target mean strength. Okay. So what is the second step? Tell me. Yeah, air content selection. Very good. So we have in the question it is mentioned that the nominal maximum aggregate size is 31.5. So entrapped air is, we have to take 0.8. Okay, of total volume. So for air content, we have to take 31.5 and 0.8, which is 0.8% of total volume, which is 1 meter cube. So we got 0.008 meter cube, right? Then what is the absolute volume?
1 minus
1 minus
0.008.
Yes. So we got step 2, we got as a air content. Step 1, we have to design as per target mean strength, which is our 5.16 Newton per meter, 5.16 MPa, right? And in step 2, we got the air content selection. Now, what's the next step? After air, what was there? Oh, after air, what was
Butter
there?
cement. Butter cement selection.
Yes, water cement ratio selection. So for water cement ratio selection, we have to mention for 4.5, we have to take how much? 0.39, right? Am I right?
Yes, sir.
No, I'm not right. We have to take for TMS, target mean strength, which is our 5.16. We don't have to design for 4.5. Oh, see, for grade designation, we have to design for 4.5 MPa, but our target mean strength is 5.16, right? Are you getting me?
Yes, sir.
So for 5.16, we have to design for water cement ratio. So how do we get this? Is as per the code, we have a target mean strength of 5 and 4.5, and based on this, we have water cement ratio. In the code, what is in the question? What is there? We have to design for OPC 43, right? For OPC 43, we have to take 5.16 as our 28 days target mean strength. When we have to calculate, it should lie somewhere in between, right? How to find this?
Through interpolation.
Yes. So we will do what? From the table, the free water cement ratio for target mean strength is 5.16. So we got 0.32 by interpolation for OPC for grade. And when we got 0.32, we have to check, because as per the code, we don't have to cross 0.40. Hence, it is okay. Right? Clear? यहाँ तक सबको clear है?
जी sir.
G. So in step 3, till step 3, we got water cement ratio. Now what next we have? We got water to cement as ratio as 0.32, right? The next step is water. Then we'll get upon cement, right? So how to calculate the water? Tell me. How to calculate the water? The nominal aggregate size is 31.5. The water content is 165. Okay, now in water content, as I mentioned before, we have to make certain adjustment, right? So in the question, we have, look at the question first. In the question, we have slump value is 25. Okay. Slump value is 25. We have angular aggregates. है ना? Now, for water content selection, the table is valid for, as I mentioned, table is valid for angular size aggregate in SSD condition, for 50 mm slump, and for other slump, like for R slump, which is 25 plus minus 10. For R slump, increase or decrease by 3% for every increase or decrease of 25 mm slump. So what is not valid here? So round gravel, crushed gravel or semi-crushed gravel, we don't have to adjust the water content based on this, because it is question in the question it is mentioned it is for angular size aggregate. Okay, and if the chemical admixture is, in the question it is mentioned that we have to use. So for table, from the table, the water content of 31.5 mm aggregate is 165, right? And we have to adjust for 25 mm slump. So for other slump, like it is mentioned, we have to increase or decrease by 3% for every increase or decrease of 25 mm. So 50 mm, 50 mm slump tha. Now we have to reduce till 25 mm, and for 31.5 nominal maximum aggregate size, the water content was 165. So 165 minus 3% of 165, which is almost 160. Okay, as super plasticizer is also proposed in the question. So super plasticizer ke liye kitna reduce karna tha? We have to reduce by 5 to 10% for plasticizer, and we have to reduce by 20 to 30% for super plasticizer. So question it is mentioned for super plasticizer. So we have to again reduce this water by 20%. So for if we are using super plasticizer, so from 160, we have to reduce by 20%. Now the new water content is
Sir,
128
160
kg.
minus G.
Yes, the new water content is 128 kg. Okay, यहाँ तक clear है? Anyone has any doubt?
Sir, please repeat this process. I could not understand.
Okay. Now see, in step 4 of our work, where we have to determine the water content. Okay. Before that, what we got? We got in step 3, we got water cement ratio.
Water cement ratio. Yes, sir.
Right. So from here, we had a target mean strength of 5.16. By interpolation, we got the water cement ratio as 0.32. Okay.
Sir.
Now, we need to calculate the water content to get the cement content, because we got the ratio. Fine. Now, in fourth step, we have a water content. So if in the question it is mentioned that nominal aggregate size is 31.5, so as per the code, for 31.5 nominal maximum aggregate size, we have to take water content as 165 kg. Now, code also says that this table is valid only for SSD condition, and only for SSD condition and for 50 mm slump. And if the aggregate is angular, matlab this table is only valid if the 3 conditions satisfy, which is angular aggregate, SSD condition, and 50 mm slump. Right? But in the question, we have the slump value of 25 plus minus 10, जो PQC का होता है. So we have to adjust this water content by, see यहाँ पे लिखा हुआ है for other slump, जो हमारा केस है 25 plus minus 10, we have to increase or decrease by 3%, है ना, क्योंकि हमारा slump 25 mm है, तो which means it is decreasing, right? So we have to decrease this water content by 3%. Okay. So the new estimated water content is 160. Since in the question super plasticizer is also proposed to add, तो super plasticizer के बारे में ये कहा गया है कि if the super plasticizer is used, we have to again decrease this water content by 20%. और अगर सिर्फ plasticizer use हो रहा है तो we have to decrease by 10%. Fine.
Yes, sir. Sir.
G. So now we got the water in the question tha, we got water cement ratio में से we got water cement ratio as 0.32. We got water content. Now cementitious content तो निकल जाएगा, right? So next step is calculation of cementitious content. Shall I move forward now? पिछले वाला समझ में आ गया था?
Yes, sir.
Okay. So in step 5, we have a cementitious content selection. From from step 3, water cement ratio 0.32, and step 4, water dosage is calculated. Now we'll find the cement content, which is कैसे? Water to cement ratio is 0.32. Water dosage is 128 divided by 0.32, right? ये गलत लिख दिया लग रहा है. We'll get the cement content. So cement is 400 kg per meter cube. Okay, by the calculation. Now when the ये शायद इधर होगा. Okay, so 128 by 0.32 होगा, which will get as a 400. So we have to again check. क्या था हमारा check? That
minimum and maximum. जी sir.
Yes,
minimum and maximum cement content.
Right. So for minimum acceptable limit क्या दिया गया है? For minimum cementitious content shall be 360 और maximum cement content 450 450 से ज्यादा नहीं होना चाहिए. But हमारा कितना है? 400.
Sir, it is 425 or 450?
450 as per the code. Okay. So for हमारा calculated cement content कितना है? 400, which is okay, which is safe, right? So in step 6, what we have to do? यहाँ तक आ गया ना समझ? कोई doubt? Any doubt? Anyone?
No, sir.
Okay. So in step 6, we got everything till cement, coarse aggregate and fine aggregate. Now we have to blend. Now again, this is a tricky one. See, now blending of this coarse aggregate and fine aggregate, we have to work. The coarse aggregate and fine needs to be proportioned wisely so as to produce the PQC with satisfactory characteristics. So we have to, for the proportioning, we have to estimate the volume of coarse aggregate per unit volume. So for the nominal maximum aggregate size, which is mentioned in the question as 31.5, for zone 2, we have to take this proportion, 0.65. So we are following the tables which is mentioned in the ISC 44, and again this table is valid for water to cement ratio of 0.50. So we have to proportion the volume of coarse aggregate by increasing to 0.01 meter cube for every decrease in water cement ratio of 0.05. Now see, our water cement ratio was कितना है? 0.32, right? And as per the code, this table is valid for the water cement ratio 0.50. Okay. Now, but हमारा है 0.32. So we have to adjust by increase in the volume of coarse aggregate by 0.01 for every decrease in the water cement ratio of 0.05. Okay. Now see, as our water cement ratio is 0.32. Okay. Our table is valid for 0.50, which is almost 0.18% lesser. So we need to adjust by increase the volume of coarse aggregate as 0.65, which is the which is taken from this table, and 0.50 is this the the limit of the table of the water cement ratio, and our water cement ratio is 0.32. Then by this we have to increase by 0.01% for every decrease in 0.05%. So this is some calculative part which we need to take care of while doing the mix design. So from here, once you'll do with your hand, you will get to know. These are very easy mathematics. Okay. So from here we got the 0.686 as our volume of coarse aggregate. Now from here our what would be the volume of fine aggregate then? Simply 1 minus 0.686, which is 0.314. Okay. Now we got the aggregate volume of air. Acha. In the question it is not mentioned, but I have to add for you people that volume of this chemical admixture was taken as 1% by weight of cement. Okay. Hello. Hello. Am I audible?
Yes, sir.
Yeah, you're audible.
Okay. The volume of this chemical admixture was taken as I have added that we have to take 1% by weight of cement. So what was the weight of cement?
400 kg.
400 kg, right? So let's take 1% as our volume of chemical admixture. So we'll have a 4 kg of chemical admixtures. Now 128 kg we got water. For cement we have 400 kg. Now we got before that we got this percent proportion for both coarse aggregate and fine aggregate. Now we'll calculate the aggregate volume. Okay. Now see. As per previously when we were discussing, I told that the mass by specific gravity into 1000 will get the volume, right? With the completion of previous step, all the masses except coarse aggregate and fine aggregate is unknown. So we'll find the volume by mass of the cement by specific gravity into 1000. We'll get 0.127 for water. We'll get the mass of water. We'll convert all this cement, water, SP and SCMs into the volumes, and we'll get the absolute volume as this 0.992. Now we'll get the volume of all aggregate. Now tell me why why this absolute volume is considered for volume of all aggregate. If you have said, if you have seen, sir, yeah, continue. Tell me. Yeah, air we don't have to consider, okay, for volume of all aggregate. So for volume of all aggregate, we get 0.992. From here till here we have 0.992, right? From here till here we have to 0.992. Now we need to get this part. So from whole 0.992 will be reducing all these, okay, all these volume. So from 0.992 will reduce 0.127, 0.128, 0.128 and 0.33. Now we got the volume of all aggregate, including fine and coarse. Okay. Now see, the mass of this coarse aggregate, we got the volume, right? Now how to determine the mass? Here we got the percent of coarse volume of coarse aggregate and volume of fine aggregate. So from total mass, from the volume of all aggregate, we will take the volume of coarse aggregate of kitna 0.686 tha, with a specific gravity of 31.5. we'll get the volume of this coarse aggregate, and for fine aggregate we'll take the specific gravity into 1000 and 0.314 will get this. Okay. Any doubt? See, mass is directly calculated using this density. Density is equal to what? Anyone?
Sir, weight by volume.
Yeah, mass by volume, right? So density, from here we get specific gravity into 1000 into volume. we'll get mass, right? यही किया है इसमें बस. Mass of coarse aggregate is specific gravity, sorry, क्या है ये? Specific gravity into 1000 into volume into specific gravity into 1000. ठीक है? These are simple mathematics. We need once you will do on your own, you will get to know. Don't worry. Now once we get the in steps, and once we get the volume of all the coarse aggregate and fine aggregate, now we'll get to know the job mix formula. But remember, this job mix design is only for SSD condition. Okay. So how to adjust? In the question it is mentioned that the water absorption for coarse aggregate is 0.5% and for fine aggregate it is 1%. So we have to adjust the mass of coarse aggregate. After removing water, we have to adjust that. What was our mass of the overall mass of coarse aggregate? 1379. So we have to reduce the water content of coarse aggregate 0.5%, which is 6 kg decrease हो गया of 1379 with 1372, which is reduced by 6 kg. Similarly, for fine aggregate, we have to adjust by removing
1%.
the water absorption. Yes. So we'll get 598 kg, which is again 6% decrease. Now, from coarse aggregate, the water is being reduced, right? Because it has, some water has been absorbed. Now, this water which is reduced is adjusted in the water content, which we got as 128. From here, 6 kg was reduced. From here, 6 kg, 7 kg was reduced. And यहाँ से 7 होगा. You check once. 9 होगा, right? So we have to adjust the water by this 6 kg and 7 kg will be incorporated in the adjusted water, and we'll get the new water as, wait, 608 by, we get the 598, right? So what was the reduction? Almost 10 kg, right? So this is 10. So it would be 143, which is adjusted water content. Okay, there is some calculation mistake. So I'll see to this. So this job mix is for, this would be 143 for water, and super plasticizer is 4 kg we got, and for coarse aggregate 1372, and for fine aggregate we got the volume in dry condition. ठीक है? Any doubt? If you have any question, you can ask me. So for the mix design for coarse aggregate and fine aggregate, blended aggregate, we have this proportion. See, in dry condition, we also have design for 31.5 mm nominal maximum aggregate size only. So in coarse aggregate, we have different sizes, right? 31.5, 19, 9.5, everything, right? So so how to adjust this in this 1372? In the coarse aggregate, we have different size of aggregate, right? So how to adjust this with different size? We have different proportions, 20%, 40%, 40%. It is given in the question. So and for the fine aggregate is 45% and 55%, and respective specific gravity is also given. Similar, their water absorption is also given. Now again we have to do for different aggregate sizes. Okay, So similar, as per the similar formula, we have to adjust we have to check the mass of 31.5 mm aggregate as a 0.7337. What was the percent? 20%. And what was the volume? 6.86. It is also given. So likewise, we'll calculate the mass of all aggregate, all size of aggregate, including coarse aggregate and fine aggregate. Okay. So the new final job mix design is this for our question. Okay. From here, we complete the mix design part of IRC 44. We'll get upon the DLC. Now you tell me, any doubt in this IRC 44? We have to, I understand we have to do calculations.
Temporary load.
Sorry? Hello?
What is the sir?
You're not audible. Hello? Okay, you can write in the comment box if you want. Am I audible to you?
Yes, sir.
Okay. So there's might be some technical glitch there. So let's move to DLC part. Okay. Now, tell me the difference between PQC and DLC.
DLC have sir zero slump sir.
And DLC.
Sir, DLC has lesser strength than PQC.
Yes. One you said zero slump, less strength. And what is the slump of PQC?
Sir, 25 plus or minus 10.
Yes. And then why do we need to provide this DLC?
Sir, it acts as a base course.
No, but you guys mentioned that the load transfer is through slab action. So if we provide a slab just above the subgrade, it can also bear load, right? Then why do we need to provide DLC? DLC is for structural support. It does not design for load transfer, load taking mechanism. It is only for the structural support of the PQC mixes. So we provide PVC sheet in between the PQC
DLC and PQC.
Yes. So why do we provide? Just it act as a separation layer. As I discussed earlier, it act as a separation layer. If it is not being provided, this all will be taken as one single concrete with inferior quality this one and best quality this one. Then more shrinkage crack will happen. Okay. And as a science of philosophy is also mentioned that a new concept of PQC is also coming, which is also known as bonded concrete. Bonded concrete. For bonded concrete, what it is still on the, like for other PhD scholars, it is a new topic to research on. This bonded concrete is something which is combination of both very good quality and inferior quality, and for that the thickness is also reduced. Here also I have mentioned I have added the wrong this thing. Oh. Yeah, everywhere it should be mm, right? Okay. mm. So we have to likewise we have to mention. So now tell me, as I said, this is for which is provided as for the separation between these two concrete structures. Okay. Now DLC is designed for, what is the thickness of DLC?
150 millimeters, sir.
100 to 150 mm, and it is designed based on compressive strength. Yes. Why it is compressive strength? Because it is not made for load. It fails. It does not fails as a bending. Okay. So see, the key point for DLC is now what is dry? What is dry here? Why it is dry?
Because it have zero strength, sir.
Yes. And lean. What is lean?
Inferior in terms of strength, sir. It is lean.
Yes. So it has zero slump. That is why it is dry. It has inferior quality. That is why it's lean, and it is concrete. So that is why it is known as dry lean concrete. So key point we have to remember while preparing DLC is we have to provide some extra width to facilitate the movement of paved tracks. When slip form pavers are working, when we have to provide additional 500 mm for fully mechanized construction, right? For fully mechanized construction, we have to take 500 mm extra width because the slip paver will slip around the periphery of the PQC. And if we are doing any manual construction, we have to take only 200 mm as a extra width. As I mentioned, it is provided for the structural stability. Now, the thickness of DLC is determined based on the volume of the road. For example, if it is prepared for major district road, MDR, or expressways, major roads such as expressways, national highways, state highways, we have to increase the thickness to 150 mm. And if we have to, for village roads, village roads or local roads, we can adjust up to 100 mm. Now, the strength of DLC is generally taken as 7 MPa for 7 days. Remember this, 7 MPa for 7 days of curing, which means in 7 days it should attain the strength of 7 MPa, which can be taken, and it is calculated as an average of 5 cubes. Okay. And when average of 5 cubes is taken, the strength should be 7 MPa. And when each cube is checked, the individual strength of each cube should not be less than 5.5 MPa. समझा ये line? Did you get?
जी sir.
आप लोगों को समझ
Yes,
में
sir.
आ रही?
Yes, sir.
Yes. So what happened when we take the average of 5 cubes? The strength should not be increased. The strength should not be less than 7 MPa, or if we are checking for individual strength of each cube, it should not be less than 5.5 MPa. But here we, and as per, this is as per IRC, and as per MORTH, which I always say that MORTH is a Bible for all our pavement engineers. So for as per MORTH, it is as a 10 MPa shall be considered, and individual strength of each cube is 7.5 MPa. So for MORTH and IRC, we have a difference. So we should not get confused in that. That is why we generally follow MORTH. The strength of DLC for 7 days should be 10 MPa, and for individual strength of each cube should not be less than 7.5 MPa. Now, for DLC, we can have coarse aggregate, fine aggregate, cement, SCM, water. For PQC, I have prepared like this, right? For DLC, where was DLC? In the layered pavement, just above the PQC, right? Just below the PQC. So for PQC, for DLC, we have a coarse aggregate, we have a fine aggregate, we have a cement, we have SCM, we have water. We have to know that because it is zero slump, Abraham law is not valid. Okay. Remember this. We have to check before doing the water to cement ratio. Acha, tell me, so यहाँ पे what happened is aggregate to cement ratio comes into play. Okay. Why? Because Abraham's law is not valid. What is Abraham's law? As I mentioned, Abraham's law is as the water cement ratio increases, strength will decrease. So in this DLC case, Abraham's law is not valid. Okay? So maximum compactness and aggregate locking should be there, compacted at OMC to achieve MDD. So we have to compact at OMC to achieve different maximum dry density. So we have different checks for this thing, DLC also. For example, for aggregate to cement ratio, see, for aggregate to cement ratio, code says that maximum we have to take 14:1 for OPC. And for PPC, we have to take 12:1. Okay. And it is mentioned that the minimum cement content shall be greater than 140 as per RC 49, and mod says that it should be greater than 150. And if we are using any SCMs such as fly ash, IRC 49 say that we can add 15 to 30% of fly ash, and mod says that we can use only 20%. And if we are using any GGBS, we can use 25 to 50%. These all are codal provision, and since we are the pavement engineer, we have to stick to the code. So these are some guidelines which we have to follow for a DLC. For the suppose chalo, anyone can you pick up any aggregate to cement ratio? Maximum is 14:1. Tell me, anyone. Hello. Hello. Am I audible to you people? So let's take aggregate to cement ratio as 14:1. So moving ahead, we have 6-7 different stages of mix design for DLC. In step 1, we have to assume aggregate to cement ratio. Aggregate to cement ratio. Suppose we take 14:1. Maximum is 14:1. We don't have to get more than 14:1, and for PPC we take 12:1. Let's take 12:1. Let's be more economical. And we have then in step 2, we have to assume the cement content. Okay. And as per the Morth, the cement content, minimum cement content should be 150. So let's take the minimum one. So aggregate by 150 is equal to, we have assumed 12 by 1. So from here we'll get the aggregate content, right? 12 into 150. Okay. Now we, in step 3 we will calculate kitna aaya ye. What is this?
1800.
1800. Right. So now we have to determine the proportion of the aggregate as per the moth. We have this gradation of 20 of sieve size, and we have to follow this code for percentage passing. Now this is calculated as per 3 methods. Right. One is hit and trial method. One is triangular chart method. One is rust 4 method. So generally we get the sieve method by hit and trial method. For example, if we get for 4.75 by hit and trial method, okay. If we get, for example, 42. So above that, how much is there? If we get
58%.
Yes, this is 42%. This is 58%. Likewise, if we get the aggregate content at 1800, so 58% will take as a mixture of 26.5 till 4.75, and after 4.75 will take 42% by hit and trial method. Okay. Now, in step 5, we have to mix the all material. We have to mix the all material, and in step 6, after determination of aggregate content, cement content, and aggregate quantity, coarse aggregate, fine aggregate quantity, we'll have to mix all the material. And in step 6, we'll determine the OMC and MDD. Generally, you might have studied OMC and MDD only in soil, right? So for DLC, I have always said this to few of my lectures, that DLC is the combination of transportation and geotech. Why? Because we have to calculate OMC and MDD here as well. In soil, we have to calculate OMC and MDD for soil, for the soil, and for DLC, we have to calculate OMC and MDD for the concrete mixture. The only difference is that we don't have to take the proctor. We don't have to take the proctor. We have to take the cubes. 150 mm into 150 mm. We have to take the cubes, and we have to determine as per modified proctor hammer. So how the trial? How is the trial? See, once we get the aggregate, once we get the cement, once we get the coarse aggregate and fine aggregate, we will add 5%, 5.5%, whatever our requirement is, up to 7% of water, and we'll cast a cube of 150, 150, and 150, and we'll determine the relation between moisture content and dry density. Just like we do in the soil part, we'll determine the moisture content, and the point where the density start losing will be act as a maximum dry density. Then we'll determine the OMC and MDD value, and it would be as optimum moisture content. The compaction is done. One more thing. The compaction of this specimen was done by a vibratory hammer. For soil, we compacted using what?
Proctor hammer.
Modified proctor hammer. What is the difference between standard proctor and modified proctor?
Weight in standard proctor, weight was 310 gram, and for modified it is 450.
I remember. Okay. What did you say? Generally, standard is 2.5 kg, right? And modified is 4.89
4.89 kg, sir.
4.89.
4.89 kg, sir.
Yes. And for standard it is 2.5 kg. And what is the difference in the blows?
There are 3 below and 5 below, sir.
Yes. Layers? Any difference in the layers?
3 and 5
3
layer.
layer and 5 layer,
Layers and
sir.
layers.
Yes. So, but in DLC, we have to compact by vibratory hammer. We have to cast cubes in spite of Proctor. What we have to do in the soil, we don't have to do using Proctor. We have to cast cube. We have to compact using vibratory hammer. And for here, compaction is done in 3 layers. Okay. And then we cast the 6 specimen at OMC and will determine the average strength at 7 days of curing. What should be the average strength at 7 days as per Moth?
10 MPa, sir.
10 MPa. And what was the individual strength? Should not be less than
7.5.
85%, sir.
5.
80%.
Yes. So again, just like OMC MDD we did in the soil, if the strength is not achieved, we have to increase the cement content and reduce the aggregate to cement ratio. And we have to repeat the procedure till we don't receive the OMC MDD, optimum moisture content. Right? यहाँ तक आप लोगों को क्लियर है सर?